Okay, so we can get started. Today's topic is how to implement collision avoidance for mobile robotics and drones, in particular using sensors and solutions from Terabee. Go ahead, Jose, next slide. So quickly on the agenda, I'll spend just 2 minutes at the beginning giving you an overview of our company. Then I'll pass it over to Jose Luis, who will explain the basics of collision avoidance, why it's important, what sensors and technologies are available, and why we use time-of-flight sensing. We'll give you an overview of our portfolio of sensors and solutions, but focus mainly on our multi-directional arrays by giving you some examples of some of our use cases, and then some instructions and guidance on how to use our systems to build your own anti-collision systems. We'll also send you at the end, or after this meeting, the PDF of the presentation, because in it there are a lot of links to documents and resources that you can use to help you in your implementation. As we can't do it all in just the 20 minutes that we have, but hopefully this presentation will be a good resource for you as well that you can use afterwards. Okay, Jose, next slide. So a little bit about Terabee. We're a company based in France. We're on the border with Switzerland, right next to Geneva. And we have expertise in 3 basic technologies. The first is time-of-flight sensing, which we use in our LED rangefinders and also in our 3D depth cameras. We also have some expertise in infrared thermopile sensing, which are used in our thermal cameras and sensor modules for thermal applications. And then finally, we have some expertise in ultra-wideband radio frequency communication technology, which we use mainly in our mobile robotics applications for locating and navigating of robots in interior or indoor environments. Next slide. So our focus today is mainly going to be on the sensor modules on the left there, and how we use those for obstacle detection and collision avoidance. But we've also deployed those sensors in a number of different types of applications. For example, in stock level monitoring applications, for example, for containers and silos to measure the level of content. We also have smart building applications, which are mainly around people counting, but also have touchless interface sensors for activating digital kiosks or digital displays. We have a number of industrial grade sensors for industrial automation and control systems. And then we have our mobile robotics applications, as I mentioned. And finally, we have a small subset of our products which we've used in more COVID-19 related applications. The proximeter is mainly like a contact tracing application. And we also have a fever screening application using our sensors. Okay, so that's a little bit about Terabee. You can, of course, learn more on our website. And for now, I just want to pass it over to Jose Luis, who will go into more detail around the collision avoidance implementation and our different solutions for that application. Take it away, Jose.
Hello, everyone. So thank you, Philippe, for your introduction. As you well said, the webinar topic of today is how to implement collision avoidance for mobile robotics and drones. I will start with the question, why do we need a collision avoidance system? Well, the first point is kind of obvious. We would like to avoid our mobile robotics, mobile robots or drones will collide and will get damaged. Many of the missions that we are doing, that those mobile robots are doing, are close to humans. So we would like to minimize the risks of getting crashed against those humans. Classical inspections in the infrastructure, like in the civil infrastructure, are made by drone, and those drones are going really far away from the operator. And in this case, the operator has difficulties to see the distance against to the objects. So a collision avoidance will keep in a safe position the drone and will allow the operator to fly and focus to check what is the structure, exactly what is the problem, what are the issues. In addition, sometimes those mobile robots are navigating in close environments. So an avoidance collision system will allow you to navigate in close proximity to those obstacles. There are different technologies to create a collision avoidance system. The classic technologies, for example, is the ultrasound, which is the cheap solution, minimal weight, small factor, and eye safe by definition because of the sound. In the other hand, we have the laser, which actually gives you high reading frequency, long range, and now we can find this class 1 laser certification, which allows to use the laser in with humans. And we have the Terabee LED Time-of-Flight, that actually is a combination of both worlds. We can get also high reading frequency with long range. We have a minimal weight and small factor, and because it's LED light, we have A certification, A safety certification by definition, and we are allowed to use multiple sensors at the same time. I would like to quickly give you an introduction of how technology works. So the LED light of our sensors goes to the object and then comes back. We measure the time, and because of this, we know the speed of light, we can check the distance of the target. Our technology has 2 degrees field of view. This means that at 1 meter, we can cover an area of 3 by 3 centimeters. At 10 meters, we can cover an area of 35 by 35 centimeters. This allows application like the one that we see here. A drone is flying on a forest and is able to detect the tree branches. When, for example, a laser scanner can do it, because the laser will pass through the holes and will give you unstable readings. If you want to know more about our technology, here in below we have 2 links where you can read more in details how our technology works. In this slide, we show you the product portfolio that we recommend for that we use for a collision avoidance. In the left side, we see the single pixel sensors, which we can quickly see the maximum and the minimum range we can get. We can go from 3 centimeters up to 60 meters, and depending on your application, you can have distance of 3 meters, 15, 40, or 60. On the right side, we have the arrays, which actually is a combination of the sensor from the left side. We have the Evo Hub, the Evo Tower, and the Multiflex. And in the webinar topic of today, we will focus on those 2, on the Evo Hub and the Evo Tower. There is a classical, so how Terabee does it? The classical way to do anti-collision law is with a laser scanner, let's say. We put an expensive laser scanner in the front of the robot, or the mobile robot, and we get thousands of points. We use other philosophy. We try to use what we call lean sensing. We think first in a smart way how to position our sensors so we can minimize the number of points that we need. So we avoid high computational power that we need to have through the laser scanner. And just with a few points placed on the right position, we can get the same performances. Those are the 2 products that we are using mainly for collision avoidance. The Tower Evo that actually it has a shape which is predefined based and because of it's a product based for the drone users. We will explain you this later. On the right side, we have the Evo Hub. The Evo Hub actually allows you to not use the predefined shape of the Evo Tower and configure your sensor in the way that you would like to do. And for example, we can see in the picture on the right that actually we have sensor places in 3D to up. If you want to do collision avoidance with your sensor, there are 2 options. The first one is to use the Hub Evo and the Tower Evo, which allows you to use all our product portfolio of single pixel sensor, 60M, 40, 15, 3M, and Mini, up to 8 sensors together, and it will take all the data, it will avoid the crosstalk, and you will have just a single output through a USB or UART, which gives you the distance in an easy way of each of the sensors. There's other option that if you don't want to use the Hub Evo Tower Evo or single pixel sensor, also work in I2C communication. They work with USB UART and I2C, and the I2C protocol allows you to use more than 8 sensors if you need more than 8 sensors together. And because of this, we have defined step by step how to do this I2C setup. However, there are many problems that can occur, or many issues that could happen if you're using this I2C communication. So we recommend that if you do it, you need to have experience and knowledge in electronics to do it properly. This is one of the real use cases that we want to show you about with our anti-collision systems. You will see this is a robot that is doing wrapping, this pallet wrapping. Here you can see this is the plastic. So the robot is navigating autonomously through a pallet, and is thanks to just 8 single sensors positioned in a smart way, the sensor that we saw before. So those sensors can create a point cloud of the pallet and makes and allows the robot to navigate autonomously through this and do the wrapping of this pallet. So it's a simple solution. You don't need to use a expensive 3D laser scanner. It's safe and it's robust. Other use case is if you are a drone user, for example, we have drones flying in forest. This video is showing a drone which has no GPS, it's just flying by itself, and the operator is not touching the controls. So the drone actually is managed to avoid the tree branches from one side to the other and keep in a safe distance the drone and to respect to the tree branches. If we are doing inspection in warehouses, we can have sometimes columns, for example, and in this case the operator is moving the drone towards a column, and the drone automatically is avoiding the column and moving left. If there are object dynamics, for example, here we see one of our colleagues that is pushing the drone to a closed environment. The drone again is flying by itself. The operator is not touching the controllers. So it's just the drone is keeping the safe distance all the time between the different obstacles. In addition, we want to say that as is in a warehouse in indoor, or drone or sensor doesn't need to have any external light. It can work in total non-light conditions. If we go to the civil inspections, here we can see as an operator is trying to see, for example, the structure of this building, and instead of focusing to not crash the drone against the wall because it's quite far and he doesn't have good reference, the system, the Tower Evo, is keeping the drone always in a safe position from the walls, and the drone and the operator can focus just in analyzing the structure of the building. The last real use case is in a European project, which the name is MOMIT. The objective of this project, European project, was to do inspections near to the railways. And the first objective was to do survey of critical parts in bridges and buildings near to the railways. And the second one was to detect instabilities of the rocky slopes. So all those two missions need to have a drone really close to those infrastructures or rocky slopes. So we integrate our systems to allow the drone get close as much as we can and get the best images of these instabilities or problems in the structures. So if you're a drone customer, a mobile robot customer, and you would like to use our sensors, what you need to know is Terabee will give you a product portfolio of sensors. For each of them, we will give you the user manual, the specification, a lot of documentation how to use it in your mobile robot, and at the same time, we'll give you some sample codes as a goodwill gesture. They are available and they are free in the website. You can use all this information to create your anti-collision law, because you as a customer will need to create and define what do you want to do with your mobile robot. You see an object, you want to stop the robot, you want to move right, or you want to move left. It's here up to you what you will do when you detect an. If you are an drone user, it's kind of similar. Terabee will give you a product portfolio of sensors, will give you specification and user manual and many other documentation related to our sensors, and also some sample codes. In this case, the difference with the mobile robots is our products are already compatible with Ardupilot and PX4. Those two autopilots, what it gives is already an anti-collision laws or object detection, and all the information related to those laws are in the wiki pages of GitHub. You, as a customer, will need to understand those collision laws, will need to configure the parameters needed, and do just the final integration in your drone. We have this table to make easier what are the products available for the different hardwares, for example, Pixhawk 1, Cube, 4, Arduino, environment like ROS or Raspberry Pi, and in the different autopilots. So in a really quick view, we can see what are the products that are available for which hardware and which autopilot. In this video, we will see also how we will guide you how to use our sensors in this case with Pixhawk hardware. We'll show you the components that you will need. We'll guide you step by step how to, for example, do the soldering pin by pin and make ready our sensors to your hardware, to the different type of Pixhawk that you will have. And also we will guide you in the different ground stations how to set up the sensor and the different parameters that needs to be implemented to make available to make our sensors work in those platforms. Also, the video, we give you a video for the Tower Evo at the same things. We give you in the video you will see the minimum component that you will need. We'll guide you how to do it step by step to make the tower compatible with the Pixhawk that you are using, and we'll guide you in the different ground stations how to use and how to set up the simple copter avoidance law. If you want to know more information and written, you will find those two links here in this slide when you will see the videos and all the information written in detail. More information useful for the drone user is we receive many clients asking that they would like to have the 360 collision avoidance plus one sensor looking down and one sensor looking up. So what we did is we create a document where we resume the schematics and the wiring of the sensors to connect to different Pixhawk hardware. We also tell you the parameters that will enable the collision avoidance defined by Ardupilot. And at the same time, we create in the same document, we have a section when we explain how to do it the same, but you don't want to use the Tower Evo. In this case, if you don't want to use the Tower Evo, there is one caution that you will need to respect, and actually I will explain you in the following slide. So our product has a numbering from 1 to 8. The avoidance collision law from Ardupilot set up one of the sensor, the first sensor number 1, as a needs to be forward. So the sensor number 1 needs to have the 0 degree respect to your drone. The sensor number 2 needs to be at 45. The sensor number 3 at 90. So this is really important. That's why the Tower Evo has this shape, is to follow and respect the angles defined by the law of Ardupilot. If in the case, for example, you're using a hexacopter and you would like to use just only 6 sensors and not use the Tower Evo, and you want to use the first in the 0 degrees, the second sensor at 60 and the third at 120, you will need you will need to pay attention because this actually is a wrong configuration. When you set up this configuration physically, Ardupilot will think that the sensor number 2 actually is mounted at 45 degrees, when actually you have mounted at 60. And the sensor number 3 will be mounted at 90 when actually it's 120. So this will do that the drone will move in a not correct way, doing actually the collision avoidance law. And I think that's it for all the is all the information we have to how to implement the avoidance collision with our sensor in mobile robotics and drone. So Philippe, I don't know if there are some Q&A questions already in the chat.
Okay, well, thank you, Jose Luis, for that overview. So I think that you'll find when you get the presentation that there's a lot of good information there and links to supporting documentation that you can use. So it's a kind of it covers all in one location. But since Jose is our expert, if you have any specific questions that you might want to ask, now's a good chance to do it. So use the Q&A space there on the lower right of your webinar interface, and you can enter your question and we'll be happy to answer them. Let me see, I think we may have one question here asking about if I have a hexacopter, can I use the Tower Evo with it?
So let's go to the last this slide. So yes, you can use the Tower Evo. Actually, you can use both things, the hub or the tower. So the tower, what it will give you is distance at the avoidance, the collision avoidance at 0, 45, and 90. What you will need to just pay attention is that there is not obstacle in the middle. You still can use the hub Evo, but what you need to do is the sensor number 2 will need to be positioned at 45, the 3 at 135. You cannot do it at 60 and 120. So you can use both things by just respecting the angles. The distance is not important. You can put the sensor at 10 centimeters, 20, 30, doesn't matter. But the degrees are really important for the collision, the control law from Ardupilot.
Okay. One more question only. Can we change the I2C address of your sensors with any of your backboards?
Yes, so let's go to, I think it's this slide. Oh, no, it's, wait a moment, I go to this slide. Oh, no, it's at the, it says here. Yeah. So it's a good question. Our sensor, we ship our sensor from our factory with the same I2C address. It's 49 in decimal. So each sensor needs to be the sensor needs to be changed. So the sensor address needs to be changed. That's why we create this step by step how to change the I2C address. If you're using the if you have just the USB backboard, you will need. No, you can use it direct. You can do it directly to with the computer. But if you have the I2C or the UART backboard, you will need to have we call a system in the middle which translate the I2C or the UART to USB, because we can do it only using our GUI through the computer. So one more time again, if you have the USB backboard, you can do it directly in the computer. If you have the I2C backboard or the UART, you will need TTL, which is transform the I2C and the UART to USB to USB form, and it can be connected to the computer directly, and then follow the step by step the procedure.
Okay, and just for everyone's, it says coming soon here because we have a document which explains how to change the I2C address of our sensors, which we will publish in the next day or two, basically. So maybe even we can send it when we send out this webinar. Okay, well, I don't see that there are any other questions. Hold on.
Maybe in the chat, check, because I cannot see anything here.
Yeah, no, I don't see. Oh, Here it is. I am in the chat. Sorry, there is one more question. I am using a Tower Evo on Pixhawk 2. How many Terra Ranger Evos can be added to it? So one tower, which has 8 sensors, how many other sensors can be added to it on a Pixhawk 2?
So what you can do is the other solution is this one. Let me go to the slide. Moment is this. So you can add 2 more because actually it depends. So it's the only with the pen of Ardupilot in this case. So you can use the Tower Evo for the 360 degrees avoidance collision, and then you can use one more Evo looking down and one more Evo looking up. After this, there is not other sensors. There are not other control law that Ardupilot allows to use or sensors. So there are three things: Tower Evo and 2 sensors, one looking up, down, and one looking up.
Okay. See. Okay, that was the last question that we have. So we're going to end the seminar, the webinar now. So thank you for your attention. If you have any questions that come to mind later, please reach out to Terabee. You can join us on our contact form and ask for Jose Luis, and he can answer any of your navigation and collision avoidance questions, whether it's for drones or for mobile robots. And certainly if he can't answer, somebody else in the company can. So again, I want to thank you for your attendance, and we'll send out to you in the next 12 hours or 24 hours the link and all the other information for this. Also, Jose, if you can just go to the last slide.
Yes, sure.
I
That
just
one?
want to put the next one.
Oh, yeah.
Voila. So we do have a few other webinars on other topics on level sensing and also on smart buildings. So if you have any interest in those, by all means, stay tuned and we'll send you the information on how to connect. So thank you. That ends our webinar for today. Thank you for attending and hope everyone has an excellent weekend. Thank you.